Hi, everyone, and welcome to Data Quality Meetup number 9. We'll give folks a few more minutes to join us and connect their audio and video. While we are doing that, in the good tradition of Data Quality Meetup, let's use the chat to type, where are you dialing in from? Awesome. Seeing folks from all over the US and Europe and all over the world. Hope you are comfortable and made yourself some favorite beverage of yours. I'm drinking some nice fresh matcha tea today, and looking forward to a very insightful conversation. We're going to kick off in just a minute. So this is our 9th data quality meetup, and in the previous meetups, we have experimented with all sorts of topics. We had a broad range of topics we've covered around data quality, doing data better, tools, processes, know-hows, how to run your team, how to better build data platforms. Today, we decided to try a different format. We're actually focusing on a particular topic, which is how to run dbt at scale. And we'll have 4 lightning talks from amazing folks from the industry who have actually achieved great lengths with implementing and scale dbt within their organizations. And we will follow up with a panel discussion with our speakers and our special guest, Sang-Won from dbt Labs. We call these talks lightning talks because they're relatively short, and they are meant to introduce and walk you through a particular topic and a challenge that the team went through on their journey. And if you are interested in asking questions in the meantime, feel free to chime in the chat. I will also be running some quick polls, so to get polls from the audience in terms of where everyone is at regarding each topic that we are discussing. And last but not least, I believe there should be a way to send reactions to the speakers. Not actually seeing this right now. Oh, there it is. Oh no, this is just regular emoji. Okay, I will let you know if I find this feature, but it used to be in Livestorm. It was very helpful in giving kudos to the speakers. Why are we talking about running dbt at scale? So dbt has become a major platform for creating and orchestrating data transformations in organizations. It enabled lots of people of various technical abilities to use best practices of software engineering while enabling creating of very valuable data assets for the use of the organizations, be that BI, machine learning, or data personalization, putting data in front of their customers. And the explosion that dbt faced in terms of the adoption in the world and the explosion of dbt adoption within organizations, I think, is unprecedented in terms of the data tools. I personally haven't seen it in my 10 years in the data space before, and that's really remarkable. And I think the really interesting infographic that Tristan Handy shared recently was that over 5% of DBT projects actually have more than 5,000 models. So I think the pace at which the complexity of DBT deployments has been growing is really remarkable. And it definitely pushes the DBT framework and DBT tooling across the board to its limits in many ways. And so I think that many of you who gathered today to discuss how to run DBT at scale are really interested in finding ways in which DBT can be scaled effectively in your organization. So we'll be discussing those topics with our speakers. So quick intro on me before I give the mic to our first speaker today. So my name is Gleb Mezhanskiy. I am CEO and co-founder of Datafold. Datafold is a platform for automating testing of your data. By testing, we mean making sure that the code that your team is writing and you're writing as a practitioner is actually correct before it's deployed to production. Before Datafold, I spent about 10 years doing data engineering at companies including Autodesk and Lyft, where I happened to be one of the founding data team members. So I got to work with lots of different tools and frameworks. Unfortunately, I didn't use DBT in neither of my workplaces before, but I'm certainly using that at Datafold internally. So without further ado, I would like to introduce our first speaker. Emily Riederer from Capital One. Emily is a senior manager with customer management data science solutions team. And for those who don't know, Capital One is a major American bank holding company that specializes in credit cards, auto loans, bankings, and saving accounts. So Capital One is a place of true data scale, both in terms of volume and complexity. And Emily will talk about how to operationalize column name contracts. So please take it away, Emily.
Awesome, thanks, Gleb, and thrilled to be here. Let me share my screen. Can everyone see my screen?
Yep, all good.
Awesome. Well, thank you again. Hi, as Gleb said, my name is Emily Riederer, and today I'm here to talk about how we can create high quality and scalable data workflows for both the developer and the consumer side of the equations in large enterprises using column name contracts with DBT. To give a brief background on myself, I'm currently a senior manager at Capital One, and over my career, I've led teams focused on delivering a wide variety of data products, everything from analytics and models to core data infrastructure like data marts and dashboards. Today, I want to talk about the need for latent communication throughout the data stack to help data scale, and how column name contracts can help provide this sort of just-in-time context, and further, how these contracts can integrate with DBT and my own DBT prior package to build more scalable and resilient data pipelines. This work is largely inspired by my background working in large enterprises. While smaller and younger companies have relatively linear data pipelines, a lot of my career has been working in heavily matrix, complex environments and organizations. We generally have countless upstream and downstream systems and dependencies, and no one single data team, but many different data consumers and data producers. So it becomes critical to figure out how to scale communication about our data and couple the data's content with context about its provenance and how best to use it. Otherwise, you run into that classic situation where peer teams and users think data is wrong just because it doesn't meet the specific assumptions or use cases that they have that you may have never anticipated. Data contracts are a popular solution for handling this at the more technical level, but the best contracts don't fully meet the need if they are hidden away in documentation and YAML files that are only accessible by other tech teams. My team had the idea of using column names as that user interface to embed both the context and the contracts in a more user-facing way. To do this, we used the idea of a controlled vocabulary. Collaboratively with cross-functional partners, we can define stubs with different types of semantic meanings, reflecting data types, entities, and other details. Then these stubs are permuted to create a rich set of descriptive, intuitive, and consistent column names. And each component of the name can attach promises or contracts to the data. To make this a little bit more concrete, let's zoom in on a specific example in the type layer. Each stub can clarify common misconceptions about a type of data. So for example, for indicator variables, it can often be really confusing whether or not they encode that positive or the negative case is the 1 or the 0. But we can define the semantics of an ind variable to always reflect the positive case. Beyond those simpler semantics, we can also attach more technical promises, like if a field is ever allowed to be null, or if it must be encoded in a certain format, like ISO 8601 for dates. Similarly with entities, we can use this sort of idea of a controlled vocabulary to get that alignment across larger and scaled organizations of what do we mean by these concepts that always trip us up, like what is a customer or what is a login. Define once, document once, use everywhere. This may all sound well and good, but of course, any promise is also a liability. Should our data ever break these promises, we're worse off than never having made them in the first place because we're essentially lying to all of our users. This is where a tool like dbt can come in handy to help us operationalize this approach at scale. In fact, I argue that column name contracts actually make it easier for data teams to dodge common failure modes like misspelled variable names or inconsistent encoding, because as we'll see in a minute, you can program against them so they improve both that user experience and also the developer workflow. Specifically in the back half of this talk, we'll touch on how dbt's Ginger templates, custom macros, and in-pipeline tests can all benefit from column name contracts. To further streamline this process, I'll briefly plug my own package, dbt-plier, which is inspired by the syntactic sugar from the R package dplyr. It basically functions to let you extract column names by pattern and apply the same transformations consistently to a set of variables. So, for example, we could retrieve all of the column names in an upstream reference dataset that start with ind. Next, for each ind variable, we can apply an average function to compute a proportion, but in just one line of code using the across macro. And similarly, we can dynamically create a where clause from a list of variable names. So how does dbt and this humble little pattern matching package help us scale column name contracts? First, consider the case of broken contracts. As an analyst, I used to find it so frustrating when a variable was named incorrectly or inconsistently, and my queries would fail simply because I failed to replicate an upstream typo. But Ginger templates can help enforce our consistent naming and definitions. By using the built-in control flow, we only have to write the logic once for many similar variables, like lags over different time periods, and deliver consistent results. Even worse than bad column names is incorrect field encoding. In my industry, precision of our results really matters. Often directionally correct isn't good enough. Early in my career, I learned I could never fully trust fields that purported to be dates or certain types of data types, because if they were actually timestamps or of an unexpected format, my date-based equality filters could exclude critical results. But with the magic of dbt and dbt-plier, we can enforce contracts like data types systemically. We can find all of the variables named with a certain pattern and ensure that they're cast to the appropriate type. Of course, there are times when you shouldn't do this. We could apply the same type of logic to casting all n variables to integers. But what could go wrong here? If those variables truly aren't or shouldn't be integers, then casting them simply masks an upstream problem instead of solving it, which again, when we're ingesting data from so many different sources, could have a really negative ricochet effects. Not only do we have bad data, but we've now made it undetectable for everyone consuming that downstream. Luckily, dbt has a solution for this too. We can use similar logic with column name contracts to write in-pipeline tests. Building off the prior example, we could identify all of those n variables and run a test for each that they're sufficiently close to being integer-like before we do that final transformation. Not only does this help thoroughly test our data as it exists today, even better, it's a flexible and scalable approach, because if more variables are added later, our tests will dynamically adapt without more code needing to be added. So in conclusion, column name contracts can improve the user experience and developer workflow to help effectively scale data production and communication in complex data environments. Thank you.
Awesome. Thanks so much, Emily. Everyone, don't forget to take a quick poll that I posted about the usage of column naming guidelines and enforcing them. Emily, and by the way, if you have any questions to Emily, feel free to type them in the chat. We'll use a couple of minutes for some Q&A. Question I have, Emily, is how do you enforce these contracts for column names? Is it something that you do as part of like a CI process, so that if someone checks in the code and they have a really, screwed up the column name or the proper data type, that would be highlighted? Or when one of those checks enforced and applied?
Yeah, definitely. And that's something you can do, I think, depending on the complexity of your architecture, either in a CI/CD process, like directly parsing the SQL, or even encoding that as part of your dbt checks. Once you've kind of run and rendered data in your dev schema, you can access all of the column names typically through, depending on the database you're using, an information schema. And I've even written these kind of tests for the validity of the fields themselves as dbt tests, kind of making sure that only allowed stubs are included, and those do have the expected data types. So many places you can plug it in, kind of depending on the rest of your infrastructure.
That's awesome. It's really great to see how deep you went into defining the proper guidelines. I've actually never seen anything as thorough before. This is awesome.
Thank you.
Cool. We also have an opportunity to ask questions to our speakers during the panel. So if something comes up, feel free to type it in the questions tab, which is right next to chat. So I'd like to invite our next speakers, Felix Kreitschmann and Jorrit Posor from FinAuto. Fin offers car subscription service so customers can digitally order their car of choice and have it delivered with a subscription fee covering everything except for gas. It's a rapidly growing platform. And I worked with their team very closely as they were scaling their dbt implementation. It's been great to see how they achieved the scale, both in terms of data and the team over the past couple of years. Felix is Senior Product Manager, and Jorrit is the Data Engineering Tech Lead. And they will talk about Supercharging Analytics Engineers, how to save time and prevent technical debt by automating CI checks. So Felix and Jorrit, please take it away.
Thanks a lot, Gleb, and thanks a lot for having us. So let me quickly share my screen. I hope that you can see it right now. So yes, very happy to be here on stage. Like Gleb already introduced us, I'm Felix, Senior PM, joined by our tech lead for data, Jorrit. And yeah, we want to focus on how to balance technical alignment and speed with one practical example, which is automating our CI checks. So what's Fin? Gleb already pitched it pretty well. So we're building the category leader for what you call a car subscription in Germany and US. And our goal is to make driving a car as easy as any other subscription service that you use, like for cars or, like for movies or music. I also listed some advantages of our product. It comes down to a seamless e-commerce experience. So you're all paying a flat rate to Finn, and customers usually keep their cars for 12 months. So let's have a look at our data setup, because while Finn has grown to over 400 employees in nearly 4 years now, we've had over 35 DBT contributors last month. So we have quite a big setup, and we also maintain over 1,800 models right now. And we have quite a high Looker coverage as well. So the DBT contributors also serve our Looker content to more than 75% of the company. And this stack has pretty much stayed the same, right? So you see BigQuery, DBT, and Looker. But what has actually changed over the time is our organization. And it has changed quite a lot, with the main conflict being balancing the technical alignment and speed, what we want to focus on today. We call it the decentralization trade-off. And I'm happy to lead you a bit through our history here. So I want to compare our organizational setup on the right to the impact on the 2 dimensions it had on the left. So we started off about 2 years ago. We're pretty similar stack to the one you've seen before. And we actually started with a small central data team of 3 contributors. So we were easily fed by 2 pizzas, right? We had daily stand-ups. It was pretty easy to align any technical topics. So the code style was clear. Everyone knew what the other one was working on. And while this created great stable pipelines and clean code, it was quite slow because we were missing the business understanding in each vertical. So the whole process from ingestion to delivering Looker dashboards was pretty slow. And therefore, roughly 1 year later, we began building decentralized data teams, so hiring analysts in each business function. And that, of course, helped to drive decisions very quickly by building anything from DBT to Looker in departments and generating business value way quicker than before. As you see in the diagram on the left, that came also at the cost of technical alignment, because you know the anecdote. So your lineage might look like a spaghetti meal. You also have ambiguous definitions of different dimensions, or teams could even cause unwanted downstream changes to other teams, which you, of course, want to prevent. And it becomes increasingly difficult to fit everything together and, for example, explain it to new joiners in your onboarding. So we also had countermeasures to that. So, for example, the central data team would review every change to the repo and also own core models, which adds some governance and also introduces some common standards in this organization. But putting an emphasis on those topics actually slowed down development again and created a lot of overhead. For example, communication, collaborating between the different teams, and also making these standards more explicit. So while becoming a bottleneck for making decisions again, so what you actually want to absolutely avoid when building data teams, we were thinking that we need to find a solution to break this frontier, not always have to compromise one or the other. And as you see, our contributors grew quite much to early 2023. So quite recently, actually, at the beginning of this year, we've asked ourselves how we can scale to even more contributors in the future and break this frontier that we encountered. And one solution from our toolbox were the automated CI checks, which is a pretty practical example. And Jorrit will provide you with an interesting deep dive on that.
Thanks, Felix. Yeah, let's now have a look on the technical strategy that we picked to get the both of both worlds, so technical alignment and speed at the same time. And it's mostly about GitHub Actions in combination with tools like Datafold, DBT, tooling, and SQL Fluff. And the things that we aim to get from those tools are code quality, code validity, some alignment on the lineage, and alignment on other policies and a lot of standards. For example, the naming convention. And I will deep dive into all of those 4 topics now. The first one regarding code quality. Here the goal is we want every code file, so basically every DBT file, look the same. So whenever you pick up a DBT file you never worked on, you should be able to read it in a flow and in a style that you're used to. And on the left side, from a user perspective, you can see uppercase, lowercase code, indentation is not good. And all data practitioners can use SQL Fluff to basically fix most of those issues automatically. So to align the code style and get something like on the right side. That's how our DBT models would look like. And also, since this is also part of our CI in GitHub Actions, so the bad deformatted code would not be able to merge. So we actually prevent or enforce this kind of linted and fixed code. Let's now go into the code validity topic. Okay, thanks. So yeah, I'm actually not sure how we would be able to work without Datafold, because I don't know, we would be tremendously inefficient by this fear of, will my change break any downstream models, systems, pipelines? And what, like, during pull request, every data practitioner gets basically an overview and can really efficiently investigate the impact of that change on the model that have been changed, but also all downstream models. And that's super important because as we are growing, we are onboarding regions, we often restructure and refactor our code also way upstream. And we always need to know if any bigger initiative or also small changes, if they make some kind of KPI broken. And on the left side, you can see an example how this looks like in a pull request. So the data practitioner would get on pull request this kind of comment, and you can already see there are a lot of differing columns and rows. And then the person can open it, and on the right side, you would see in those bars. And if you have some kind of deviation in those bars, that means like before and how it would like after pull request. And if your code change cannot explain this deviation, you have a hint and you might want to jump back into your code and look if there's a mistake. And you get this basically for your change models, but also all downstream models, and you can basically really efficiently evaluate before and after. And that's really like something that we actually is super crucial to stay efficient and make changes like multiple times per day everywhere in the pipeline. And let's now go into the lineage topic. So regarding lineage, Felix already mentioned it, the spaghetti lineage. So we have some kind of data flow that we want to see, which we closely try to align with communication patterns in the teams and the org structure, bringing those aspects really close together, borrowing some principles from data mesh. And also here in the CI, we can basically check that this reference here in red, this would not be possible. So someone doing this in the code would not be able to merge into our DBT mono repo. And this is like super helpful in terms of, okay, we have this target lineage and we want to keep it, but also as soon as we have a new lineage or we onboard new regions or other bigger chunks of data, we can basically predefine the target lineage and then make sure that it's basically rolled out and followed across all decentralized data teams without communicating about it. It's just enforced during pull request. Okay, then we can go now into other policies. And here it's about naming convention, owner. So on the left side, you can see a list of checks that are run during pull request again, but also can be run on the local machines of the analysts and analytics engineers. So hard-coded references, owner tags, certain tests need to be in place, then the column naming conventions, and so on. So we have a big list of changes of policies and rules that we think are important. And on the right side, you can see basically configuration. So whenever we have something, it's basically at its core, it's a Python file that is executed on pull request. And we just have to basically hook it into or put it into this list of checks. And then on pull request, every changed file is checked to, that whatever we define in Python is according to what we expect and want to see. And this brings me to the conclusion. So all of this, like one thing to keep in mind here, at Fin, we basically have one central data team with the mission of making analysts more efficient. We even have a KPI for that, perceived analysts productivity. So therefore, all of those things are driven by our belief that one team should basically just optimize how the other decentralized teams are working, but this also means that you are actively investing into this. So the stuff needs some integration, needs some maintenance. Whatever rule you define in your pre-commit checks, you also will get a lot of false positives or false negatives. So there is some stuff to maintain, but we think this investment is really like beneficial, because what you get in the end is it's just like a multiplier. You get increased development speed across multiple decentralized teams. All teams are technically aligned without speaking to each other that much, so you can reduce the communication overhead tremendously, and also policies are made explicit. So whenever someone starts new, the person does not have to learn a lot of like a list of policies. It's just part of the merge request and the natural development flow, and people learn it by doing and running against a check, for example. And yeah, that's basically it.
Thank you so much, Felix and Jorrit. That was really insightful. Also, thanks for the shout out. I think what I really loved about your the narrative is that how you approach thinking about speed versus quality and technical alignment. And I think that in many times we think of this as trade-off, almost like we have to either ship very fast, but disregarding a lot of the proper ways of doing things like testing and quality checks and aligning on, you know, SQL formatting and column naming conventions, right? But I think what you've done really amazingly is kind of shifted the entire frontier, right? Just moved to a different frontier with regards to that trade-off. And I think it's a really, really powerful mental model to think when you're, you know, scaling data platforms in organizations. I would also encourage everyone to vote in the polls. I'm particularly interested in the topic of CI, because I think that a lot of the kind of best practices and solutions that we heard today from Emily and from Felix and Jorrit, they kind of depend on the ability to automatically detect and enforce things, be that, you know, column inconsistencies or any kind of data quality, you know, testing or impact analysis, and CI, which is the way to, you know, build a staging environment and run out those checks for every change that is proposed to be deployed as a really central process. I'm really curious how where everyone is with regards to implementing CI with DBT. I think there's a question from Christopher. How do you enforce rules where tables from reporting layer won't reference tables from the source layer, as in your diagram?
Yeah, we basically have naming conventions for the models. So the models follow a certain naming convention. So a model can be identified according like where it lives in the layer from its name. And therefore, if we have something on the source and something on, I don't know, dimension, and we know dimension is only allowed to reference stuff from integration, for example, we can just do this by naming and then having actually rather simple Python scripts and check the from statements and see if the from statements follow this kind of reference in terms of the naming conventions.
I think there's also a question about CI. How long does CI take to run for you? If you build, do you use Slim CI? Do you build the entire project?
We use Slim CI, so only changed and downstream models are built. And I don't have a number. I think like it's around 5 minutes, maybe 10 minutes, something like this. Rather 5, so it's not that huge.
Yeah, that's actually
we also
really
have
fast.
rather fragmented data and not like huge amounts of data. So again, I guess it will depend on your volume and so on.
Awesome. Yeah, also shout out to DBT Labs for building Slim CI. I think it's been like a really big efficiency improvement feature for implementing CI. In a nutshell, it basically allows you to reuse data from production when you make a change, so you don't have to spend unnecessary compute. Awesome. All right. A few more topics I want to dig in with your talk, but we'll leave that for a panel, so we can also have other speakers chime in. And I'd like to invite our next speaker, Alexandra Gronemeyer, who is the lead analytics engineer at Airbyte. And I think many of you today know what Airbyte is, or are even using Airbyte in your workflows. For those of you who don't know, Airbyte is the leading open source ELT platform that replicates data from applications, API, databases to warehouses. So it helps you integrate your data and then use dbt to make it useful for your downstream stakeholders. So Alex, please take it away.
All right, you can see my screen okay? All right, thanks for the intro, Gleb. So my name is Alex Gronemeyer. I'm a lead analytics engineer at Airbyte, which Gleb gave a great intro to, is an EL integration tool. So moving data from source to destination, usually the first step in your pipeline when you're using a tool like dbt. And I'm going to talk to you about how we are running dbt at scale. So our agenda will go over what data looks like at Airbyte with the data team and what our data stack looks like, some of the growing pains we faced, how we've scaled dbt, what we've learned while doing that, and then what we're excited about next. So jumping into data at Airbyte and our team structure, our company size is currently around 90 employees. So definitely startup, very different from some of the enterprise use cases. But for us, this is scaling quite large for where we were a year ago. Our data team has 2 people, and we run sort of a hybrid team structure right now. So the Fin team gave a great overview of central versus embedded data teams. We kind of have a mix of both. I'm the single analytics engineer in the engineering org, and we have a data analyst in our product org. We work really closely together. Might be hard to see, but there's a little dotted line there on the screen between us, and we collaborate really closely. And then we also take requests from the other business functions within the company. And here's what our data stack looks like today. So we bring in data from over 30 different sources. We're using Airbyte Cloud to extract and load different API and database sources into Google BigQuery, where we're running all of our dbt transformations. And then we're using Metabase for all of our visualization. That is where end users are interacting with our data today. So some of the growing pains that we face, scaling a startup comes with a lot of growing pains. So as I mentioned, we grew quite a bit over the last year. We, this time last year, had about 20 employees and now have 90. So that's a really rapid growth to almost quadruple the team size there. And then we also, in that time, started selling a cloud product. So that comes with a lot of requests for data and people who want to see how that product is performing. They want to see activation, revenue, lots of really important data sets, lots of eyes on the data team in that amount of time. And there were 3 common issues that we faced over the last year. So the first, we have a lot of really useful business tables, but people don't know where to find them or what they mean. People aren't always even familiar with the concept of a business table and why they should use it. So we have an enablement and education gap in the data that we're building. We also have a lot of people at the company who know what dbt is. It's talked about a lot at Airbyte. There's a lot of great partnership between the products there. They want to contribute, but they don't know how to get started, especially with our internal project. And so people want to contribute back, but with a small data team, we needed documentation to tell them how to even get started with dbt and what our structure looks like. Especially, this is mostly coming from the engineering org, so they might not have familiarity with a traditional analytics engineering pipeline. And then we also have people who are relying on reports in Metabase, but when we started building our dbt models, we would just run them daily. There wasn't a lot of intelligence behind how often we were running these or frequency, and that was fine at the beginning. It was unnecessary to run it more often than that, and it just brought up our expenses. But as we scaled, people were growing impatient with waiting 24 hours for the next DBT run for their reports to update the Metabase. So how we went about scaling DBT, the first thing that we looked at addressing was people not knowing what a business table means or how to use it. So we took advantage of DBT documentation. We started documenting all of our business tables and all of the columns within those business tables as a starting point. And then we're using the DBT Metabase package to push that documentation into Metabase so that it's centralized and lives within our source control. It's available in BigQuery and also available in Metabase. We also wanted to enable people to contribute to DBT. So we started out on DBT Core, but we actually recently migrated everything into DBT Cloud because this lowered the barrier of entry for people being able to contribute to our project, especially less technical teams who didn't want to go through the process of installing VS Code and different packages and things like that. So this was super helpful in just making DBT more accessible to the rest of the company. And then we also created a contributor guide, which is just stored in source control in our GitHub repository, and it's super easily accessible, lives within the code. So it's in people don't have to hunt for it in Google Docs or Notion or places like that. It's right where the code lives, and it tells you exactly how to get started in DBT Cloud, specifically with our Airbyte warehouse project. And then we also looked at improving our DBT runtime. So as I mentioned, we started out just running DBT once a day, and that was fine at the beginning. But if we wanted to run that more frequently, basically the cost would just scale linearly if we didn't make any changes to our models. So the first thing that we looked at doing is creating incremental models. So this is just an example of what that looks like in a few of our tables. And if you've worked with incremental models in DBT, they're awesome, but they're also, you have to be careful to make sure that you're not missing data that gets updated, that especially when you're joining with other tables, that you're aware of how those incremental models will behave downstream. So this is something that took a lot of thought and effort, and we didn't just make everything incremental. We picked specific models where it made sense, like our segment event tables, for example. And this improved our DBT runtime by 75%. So our DBT run was taking about 30 minutes when we were running it daily. And we brought this down to 7 minutes, which was enabled us to run it hourly and not worry about our costs, our cloud costs exploding. And some lessons we've learned throughout this process. So one of the most important things is just meeting our business users where they're at. So we needed to understand what problems we had with adoption of data at Airbyte and getting people to be more data-driven and self-serve. And we couldn't make those decisions in a bubble with the 2 people on the data team. We needed to gather feedback from our business users. We did this mostly in Slack and just meeting in person because we're a small enough company, but surveys would be another really great way to gather feedback from teams and make sure that we were solving the right pain points. Also, iteration is key. So we didn't roll out all of these changes all at once. We'd made small incremental changes over time and validated that it was the right direction. So with regards to documentation, for example, documented one business table, pushed that to Metabase, got some user feedback, incorporated that, and found that that was the right way to go. And then one thing that we learned, a little bit contrary to maybe what the direction we wanted to go in, but simple solutions were the best way to go. So there are a lot of really cool tools and strategies out there, especially great conversation in the previous presentation on CI. We're just not there yet. And actually adding in all of that CI and tooling now made DBT less accessible to other teams and like more intimidating for other teams who wanted to use it. So we definitely want to get to that point. But we had to scale some of that back for now to make DBT just easier for people to contribute and use. And then that kind of leads into the conclusion here around what we're excited about next. So we definitely want to grow our data team and our power users. I didn't mention this earlier, but we do, in addition to the 2 people on the data team, we have probably 5 to 10 power users also using Metabase and occasionally contributing to DBT. So we really want to scale, continue scaling the people who are contributing to our DBT project. We also want to add more DBT documentation and tests. I mentioned we are documenting all of the business tables today. We also have tests, but they're really basic, null and unique checks. So those could be more robust. And as we encounter issues, like data quality issues, we make sure that we are building tests so that that doesn't happen again. And then adding in observability and quality checks is definitely next on our list. One of the biggest pain points we have today is making changes in DBT and knowing if that is going to break anything in Metabase. So that's a huge gap for us today, and something that we would love to solve. And then, of course, I had to shout out AI. We're always trying to figure out how to incorporate, all the new advancements in technology into our current data stack. So that's really exciting, especially when you look at scale. There's a lot of leverage to be built in that area today. All right, thank you. That's the end of my slide there. I saw there were a few questions, so I can, great question on what is a business table. So that ends up being our final table in our DBT model that gets exposed in Metabase. And you can think of this as like we use the one big table format. So everything is pre-joined. We try to be really intentional about the granularity of those tables. Column naming becomes really important because we want it to be very intuitive to someone who's not a data person to know how to use that table. And that's really meant to be like your access point into our data, especially from Metabase. And then as far as distributing DBT docs, that's a great question too. All of our docs are available in DBT Cloud, which is super helpful. So we have a lot of users who have like read-only licenses and are able to access those there. And then we're also using the DBT Metabase package to push some documentation into Metabase directly. And we've also experimented with data catalogs as well, which leverage a lot of our DBT docs. That was one of the places where I think we introduced that too soon. We're not ready for a data catalog yet. So it's a really great tool for the data team, but it hasn't gained traction with the rest of the organization yet. All right, checking any other questions.
The question from Lindsay.
Oh yeah.
What kind of questions are you asking in the feedback sessions?
Yeah, it really depends on the audience. So if we're talking with engineering, those questions look really different. And I think where we found success is like walking people through the questions they're trying to answer and how they go about building that in Metabase. Engineering comes at it from a much more technical perspective, and they're more willing to like brute force SQL queries and try to get things working. Whereas like a salesperson who doesn't know SQL has a different approach to Metabase. So I think walking through their use cases is really helpful. Also, when we implement something like documentation, asking people what they think about it, showing them the documentation we created, and having them just give us feedback is really helpful. Occasionally I do Slack polls for that too. If I'm trying to be more async or reach like a wider audience, I'll say like, we introduced this new documentation. What do you think? And that's worked well occasionally too. We're a small enough company that I think it works for now.
Awesome. Thanks so much, Alex.
Yeah.
Great talk. And I think there's one more question. I'll let you answer that. Maybe I think you can type it in the questions tab. And I'd like to transition us to our last but not least lightning talk by Jason Jones, Analytics Engineering Manager from Virgin Media O2. Virgin Media O2 is a British mass media and telecommunications company that combines over 46 million of broadband, mobile, phone and home subscribers and Jason is going to talk about how to scale DBT from 0 to over 200 people, which I found really mind-blowing. I think this is an example of a data team that operates at almost like a planet scale. So Jason, super excited to hear from you. Take it away.
Yeah, I like that reference, planet scale. Not heard that one before. Yeah, I'll just share my screen. Hopefully you can see my screen. So, yep, today I'm going to talk about scaling analytics engineering with DBT at an enterprise level. So, as Gleb introduced me there, I'm Jason. I'm the analytics engineering manager at Virgin Media O2, and the area that we particularly look after is analytics engineering in the data platforms environment. So that's essentially the area that is the horizontal to many vertical teams, but I can explain that in a minute. It's kind of like a hub and spoke model where we kind of lay the foundations. So Virgin Media and O2 have essentially set on the path of digital transformation, and what that entails is moving all our on-premise servers and technology and anything to do with data into the cloud. Whilst this was happening, we also had the merger of two companies. So we have Virgin Media and O2, which historically were two separate companies, which have now merged. And whilst doing all of that, we also had to migrate the data, the tooling, and upskill all the analytical teams on the now cloud tech stack. So what tech stack do we use? So what we've ended up with is we now use Google Cloud, DBT Cloud, and Looker. And then we also use Okta for authentication and also GitLab for our version controls. We do have other tools as well, but these are the core of what we basically use day to day, moving from on-prem to the cloud. And what sort of scale are we working with currently? So at the minute, we have 120,000+ queries that directly hit our central models, not necessarily these are the hub models, not the spoke. We've found that we're saving in excess of 100 hours of technical debt per week for the analyst teams by moving to DBT in this environment. The 60+ deployments by the wider team in a month, which at the time was very unheard of in an enterprise. We have around 2,000 merges and merge requests in the last 3 months, just from DBT alone, 11,000+ pushes in the last 3 months, and we're currently running at 23 or just slightly over separate DBT projects. And all these numbers cover 10+ analytical teams and data science teams. So how do we scale from 0 to 200 in a team of 9, but not also become the blocker due to the size? So these are a set of books that are quite useful. One's called the Phoenix Project and the Unicorn Project. And the ideals that I took from that and the mindset I've got on screen. So these 5 key ideals, which were from the Unicorn Project, and those are locality and simplicity, focus, flow, and joy, improvement of daily work, psychological safety, and customer focus. And these were the patterns and the thought process that we went through when we started to scale. And it was something that we always kept in the back of our mind of how we need to work to make this a success. So going to the first ideal, locality and simplicity, we have code. This relates to code and processes. It should be as simple as possible, and they should also be local to each team so it doesn't affect other teams. So how do we do that on the ground in DBT? So for locality, this could look like DBT projects based on the team themselves. So each team has a DBT project that doesn't interfere with another team. And simplicity, this could look like a simple communication process that's not restrictive. So for example, we use Slack and we have specific channels within Slack for help and support. Focus, flow, and joy is the second ideal. This essentially relates to working in small batches with quick feedback and reducing the restrictions. So as you can see on the screen there, we have our analytics engineering team, which builds central data models to feed the hub. This is the hub, and then it feeds the spoke teams out in the company, which we also look after. And then what happens is we have this quick iteration. We feed out data and data pipelines and information out to the separate teams. They then improve and add value to that and share it into the central area. And once that's regarded as golden and, you know, fully tested and workable code, we then have a process where we bring that back into the central source and use it as a source again. So there's this constant feedback loop of leveraging the other teams and their specific knowledge in certain areas to then feed that back into a central area, which then can feed other teams that aren't specialists. So the third ideal is improvement of daily work. So work should be better than yesterday, and tomorrow should be better than today. So this relates to just constantly the continual improvement of what we do. So examples within DBT of that would be, for example, we have a central DBT package, which is internal to us, and that's built with versioning, and it contains standardized code. We then push that out to the other teams to make use of within DBT, and it helps to keep a central place for certain specific code that then stops duplication and extra effort. Another example of that would be guardrails. So one of the guardrails that we found previously in the on-prem world was there was a mistake where if we allowed teams to access another team's UAT environment, they would then build on top of the UAT environment and then push that to prod. And what we found is a bit of a spider web of data flying around with not much visibility, where UAT from one team was actually powering the production data sets in another team, which obviously we don't want. So we had guardrails put in place now to stop that. But we also have a process in place that people can still get access, they just can't use it in production. And then there's 8 key points on the left-hand side, which are kind of key principles that we go with to help make the improvement of daily work a bit easier for everybody. Psychological safety is number 4. This is often overlooked, but it's really important. So we've got to make a culture that's open and can take calculated risks and allow people to speak up, share ideas, and innovate. If they don't do that, then things tend to slow down and stop, and you find that you don't progress as fast as you need to. And the last one is customer focus. So the 5th ideal, we should always build something that the customer cares about. So when you're building a product or a data pipeline, it should be something that has customer focus at the heart, not necessarily a back-end system. So an example of this would be build data sets and data pipelines that feed into the website rather than data that feeds into an internal report with unknown stakeholders. And then how would I do that when I'm trying to scale an analytics environment in an enterprise? So I always follow the 80-20 rule, where I focused on key 3 areas from the beginning, which was to build the DBT and GCP environments to enable other teams to work at pace, create a cross-team process for communication, and then remove restrictions proactively before the other teams came across the issues. Another approach that we found on top of this is scale first, then mature. So when you're building out a technical solution, you should always, especially if you're trying to scale, build it out in the least restrictive way to what your minimum standards are. Deploy those foundations far and wide across the department or team or users, and then mature incrementally in each area that you then decide needs the maturity to be added on top. So for an example, we have a basic Git development process on the screen. That's what all the teams started out with. And then from there, we've matured that and added, for example, CI/CD on top, different branches, and some teams actually push straight to production without a UAT layer. They tend to be the more advanced teams. Again, this comes back to the previous talks of speed versus best practice. From experience, what I tend to find is speed is usually driven by the business, and best practice is usually driven by the developer. There's always a balancing act of which way you go. So some key points that I'd like to make clear really is don't build tactical or hacky solutions. It just only incurs technical debt in the long run that in an enterprise you tend not to pay off. Always build a minimum viable product of the long-term solution, even if it's not as feature-rich as a quick and hacky version. And an example of this on the ground would be, if you can performance tune your SQL code to be 20% faster, is it really worth holding back the release of that code and that data if it's going to take you 3 times longer to develop? So the key takeaways is start simple, get people building with the minimum requirements that you need, then add maturity on top. Create local environments that don't cross team boundaries. Avoid tactical and hacky solutions where possible, as it just increases the technical debt in the long run. Have team ownership with a team that has ownership of GitLab in our case, the processes and DBT, which also have visibility of all the other teams that we manage. And it just tends to be a hub and spoke model with a central team looking after the foundations. And then implement guardrails to stop mistakes, but importantly, don't block progression. So for example, we have CI in place, but it doesn't block the merges. It just warns the people who have done the merge, done the code, that there's an issue. And then once all that's taken place, and you follow that sort of mentality, what we've ended up with is multiple teams that are developing unrestricted. They've got easy collaboration between themselves, and they're free to innovate all within DBT Cloud. So it tends to work quite well. Thank you.
Awesome. Thanks so much, Jason. Again, the scale, just the numbers that you showed, like 2,000 pull requests or merge requests merged in the last 3 months. It's really, really incredible. And I think the one particular principle that's really stood out to me is scale first and then impose restrictions. I think from my own experience being in a platform team, I definitely made a lot of mistakes trying to put the best practices on people from day one. And that is a sure way to not get a lot of users adopting your platform. So I think that the way you approached it is makes a lot of sense.
Yeah, we found that solution tends to be the overall best way. It's obviously there's always a balance, and when when I'm developing, I want the absolute best way of doing something, but that's someone who knows what they're doing. But in terms of scale, it doesn't work. We did have many of the teams had varied skill sets, so it wasn't just everybody was the same. It was some teams were slower, some of them were completely fresh to these tools, and then some of them picked up very quickly. So like, for example, data scientists, they were more advanced in their skill sets. And yeah, the balance ended up being we have to scale first, get people moving, and then come back and mature, which isn't always ideal. But if you can make time for that, then you tend to get the value quickly, and then you start tightening up afterwards. But yeah, you still need some minimal rules. You can't just throw bad code out everywhere and let everybody run free too much. You need some minimum standards.
Yeah, makes a lot of sense. Really, really awesome work, Jason. I'd like to transition us to the panel discussion. There are a few topics that I'd love to dig in with our speakers today. So yes, I think we have everyone here. Please don't forget to unmute if you're about to speak. And the first question I have is actually for Sung, who is a solution architect at DBT Labs. And Sung, I'm really curious kind of about your reflections on implementing and helping your clients and customers implement DBT at scale, because I'm sure you've probably seen things go really well and things go not well. And maybe reflecting on some of the topics we raised today and your experience, what are the things that you've learned that you wish everyone kind of knew, or some of the major mistakes that you think companies can avoid when either starting to implement DBT at large scale from the get-go or scaling DBT really fast?
Yeah, great question. I've seen dozens and dozens of things. Quick anecdotes, I've seen people just copy and paste stored procedures into DBT models and kind of hope and pray and wipe their hands. I've seen people run single jobs, one model at a time, and then chain those jobs together. just because the paradigm was just so net new to them. But those are extreme stories that hopefully none of the people here have ever encountered or will ever be tempted by. But I think the biggest thing is, I think, Jason, you did a really great job illustrating this, even just like the through line and tone of your conversation where, and I think this is just true of software, where tech is not our salvation, people are. And, you know, what I heard in terms of why DBT made you folks successful isn't necessarily because DBT in and of itself has this like magical power for people to do things. It's because your team had strong opinions and backed up those opinions with evidence that, hey, let's do it this way at this context in our season of maturity. And you stuck by that, right? Versus I see a lot of times people, they start off and they think like 1 week of charisma of just like, hey, let's just do it things this way. But then they capitulate when people start complaining at them and they just loosen their standards so much where it just becomes another spaghetti mess by a different flavor, right? And so I think it's tempted to go like, ooh, like let's go into this niche feature and that'll be the silver bullet to solve people's problems. No, it's people solve other people's problems. That's what it is at its core. Now, in terms of enabling that, I've seen the meta play out this way. You know, I think it's tempting, especially when you start off, even if whether you're a small or big organization, just go, hey, let's go straight to multi-project. Let's have a finance DBT project, supply chain, et cetera. Hey, let's go straight into let's create the most custom bespoke GitHub actions or GitLab pipelines to do all these like very nuanced things. But sometimes you're so tempted by that, you're successful at the wrong thing, right? Where it's like, I built all these beautiful models, but if no one is using it and they're just like, nice Tableau or whatever BI dashboard sung, export to CSV, copy and paste it in Excel, move on with my life. Did you really win? And I hope all of us kind of, you know, think, no, that's not winning. And so just saying, you know, in a tactical perspective, hey, just start out with a monorepo, keep things very simple. Sometimes you really can get away with, hey, I only have like maybe 100, you know, DBT models. I have some simple star schema data model with, hey, here are all my transactions to calculate things like revenue by month. Here's some other dimensions like customers and addresses and, you know, clickstream sessions, all that fun stuff, and just move on with my life. My DBT job is DBT build, and that's it. Because it only takes maybe like 30 minutes to an hour, depending on the size of your data. And people can get away with that for a couple of months. And that's a great thing. I think what really matters is less about, hey, look how cool my code is, and like, oh, whoa, Jose from accounting is actually using my gosh darn work and is bragging about the data that's powering it. They are not, you know, the metrics isn't like, hey, like, let's just look at uptime for data pipelines. It's, hey, like, how many times is Jose complaining to me? Is that number going down into the right? Hey, how many times is Jose or someone else from another team bragging about our work and saying, hey, like supply chain, we've heard great things from the finance team. Let's go about it from there. And so it's really about securing those early wins and building champions, you know, across business units so that they celebrate the data team versus just like, oh, like I just play hot potato with them through Jira tickets and that's my only, you know, rapport with them. And so that's what I've kind of seen, you know, in terms of avoiding common pitfalls is start simple and then you can, you know, tackle complexity one module at a time versus trying to big bang and go niche all the way up front. So yeah, that's my answer to that.
Wow. I think you've distilled some really great wisdom here, Sung. And the people first approach, not the tech first approach, I think resonates really strongly with everyone. And also, I think we've kind of seen it through a few talks today, because I think all of the solutions that, you know, the successful solutions that, you know, Felix and Jorrit and Jason and Alex and Emily talked about, they were all targeted at actually how to make people more successful, how to make it easier to do the right thing. And I think that's a very, very powerful mental model versus how to like optimize for scale from the perspective of just making things run, you know, faster, which I don't think anyone actually talked as much today, which I found really interesting. I think all the problems we try to solve indeed were the people problems. So with regard to scaling DBT, I think that what's interesting is that many teams who are here today, and definitely a few of our speakers, have scaled DBT either from, you know, a team of 2 to over 35 people or 0 to 200. I'm wondering how you think about what is the total addressable market for DBT in your organization, do you think that you've reached everyone who you want to be able to contribute, or there is bigger potential? And what do you think stands between your current, let's say, penetration of analytics engineering in the organization and the full potential that you'd like to get to? I guess curious to hear thoughts from Emily, Felix, Jorrit, Jason, Alex, all of you implementing DBT for your teams, basically.
Sure, I can jump in and go first there. I think one thing that I personally find really exciting about DBT as a framework for scale is I think SQL is generally like kind of the most approachable for like the kind of like lingua franca throughout like the data science community or like the data community at large. You know, I mean, I think some pockets may use more SQL and Python or SQL and R or just SQL and Tableau or something like that. But I know I was really inspired by kind of like Alex's talk, especially. I think of kind of hearing about how to get DBT to not just be a tool for analytics engineers, but really taking full advantage of SQL being that lingua franca to, you know, be kind of like pulling the best of the best of what's data science building. What are data analysts building for the like 7 teams doing similar types of funnel analysis, putting those in packages and pulling them kind of like further upstream and more centralized. So I think in my mind, it's almost like getting away from thinking about analytics engineering as a role and more thinking about it as a tool or a mentality that all data practitioners in your org adapt.
Makes a lot of sense. Yeah, Jason, go ahead.
Yep. So in terms of the total market internally with Virgin, in my head, I would like everyone who touches data to be using the tool or the new tools. But in terms of bottlenecks, there's probably 2 layers to that. So there's the technical. As I said at the very beginning, we're doing migration from on-premise servers into the cloud. So that naturally has to take, you know, time across the company for all the other teams elsewhere. And then also it goes back to the people problem of we need to, you know, change the mindset of these teams because they've worked certain ways for so long. And then we need to change that and show them the new way and the, you know, the sunny uplands of the future and the modern tech. And, you know, we have to share the benefits of what we've done with them to convince them. But once that, you know, once we do that, we tend to find that people come on board quite quickly, which is good. And then from there, you know, we just keep expanding. So there's still some growth in what we do yet, if not 10x growth eventually, which is quite crazy to think about considering the size already.
Do you remember correctly that your next milestone is 200 to 1,000?
Yeah, that's the aim. That should hopefully not cause too many issues. It's an interesting scaling problem because I think you kind of go through stages of, you know, small startup mentality of 0 to 10, for example, and then you hit the 100, and then you hit slightly different issues and problems, and then I tend to find now we're kind of plateaued in, you know, in the problems. We kind of had the solutions baked in, and so we don't see we can 200, 300, 400 potentially might not be an issue. It'd be interesting to see when we hit the 1,000 or so what challenges that's going to bring. So, but that's the long-term goal, if not more.
That's awesome. Even 300 people is like 10 Datafolds. Awesome. Felix, you're curious about how you're thinking about and your bottlenecks.
Yeah, for us it became quite. For us it became quite natural that also, for example, our engineering department began to use DBT, and they also like it to integrate in their processes. So, for example, they they take some data sets, they build it, they figure out what they want, they build it in DBT and include it in their like normal workflows, for example, to AWS Lambda function, etc. And that worked pretty well. However, I think you need a really good onboarding, so they consider it as part of their option space and not stick to their old patterns and make the entry barrier quite low. And also, you also need a close collab between the data and engineering team, that you avoid double work, and also try them making like use of the canonical source that are already there and not build their kind of shadow pipelines and completely in a different direction. So I think a good onboarding, low barrier, and a close collab with the other DBT contributors is a good way to go.
Awesome.
Yeah. Maybe regarding addressable market, like from the customer, like our customers, our internal customers are basically people that need insights to make decisions. And there are still a lot, you still need some kind of pipeline of people and many different roles to deliver those insights. And like in my opinion, like getting the insight that some business person needs should be as easy as like Googling for like restaurant ratings and finding something. So I'm kind of curious how this whole like language model thing maybe might pay off, enabling people to interact with data with natural language. So basically DBT already like lowered the entry barrier, like making basically data more accessible. But I think ultimately, like the ultimate user that doesn't speak as SQL in the end, or often doesn't, and it's even too hard to like work with BI tools, because also BI tools need some kind of learning curve. But we all can speak and ask questions, and that's something that I'm super curious of, with like DBT and documentation, and especially like defining metrics and dimensions in documentation, if they might boost and make data more accessible through natural language.
Yeah, that's a great point.
Really great points. I was just going to add, I think one of the bigger issues that we found is like knowing SQL is not the same as knowing how to model your data. And so I think one of the challenges that we've run into is people know SQL, especially engineering, knows SQL really well, but doesn't always think of things in terms of data modeling and like how to build out a data warehouse, as opposed to like a transactional database, or even just like querying the raw data. Like they're more than happy to query raw data generally, but building out the models has been probably the biggest challenge in training people. So that's been really interesting, and we're still working through how to train people. And Emily, your point really resonated with analytics engineering being a mindset instead of a role. And we go back and forth on that all the time, because teaching the mindset is really hard. So it's like, should we just hire the role, or should we try to teach everyone this mindset? And that's sort of where we're at right now. So yeah.
Awesome. Thank you for sharing, Alex. Something I'm also curious about is as DBT becomes and analytical data pipelines become more and more, hopefully, source of truth for the business, and that data gets used in a variety of applications, not just maybe ad hoc reporting, but business intelligence, machine learning, but also probably putting that data in front of your users or board members, or even public companies, or regulators. How does that affect the needs for data to be accurate and within I would say like the compliance efforts? So there's one thing when you're serving data pipeline to a data scientist who does something like it does a deep dive and then goes in and presents the data in front of let's say even the executives, right? But another thing is when this data actually gets in the hands of either your customers or regulators or general public. So are you at a point where you are thinking about compliance when you scale DBT and pipelines? And I'm also curious Sang's opinion on that, because I'm sure that you come across different types of customers that are probably, some of them are being highly regulated. You don't have to type, you can talk.
I can go first. So I kind of have like two stories here. One, I won't name the company, but they are a healthcare startup that uses DBT to ensure that prices are compliant, for certain claims, for example, and like reimbursements. And there was just like this really cool anecdote that someone shared with me. I was like, wow, like we made sure we weren't overcharging this person by thousands of dollars because of a check we had in DBT. And we were able to resolve that pretty quickly. And I noticed as DBT has matured and people are like settled with the mindset that it isn't just being used for historical analysis like revenue by month. It's becoming more embedded and sitting in between that land of like historical analysis / like part operations. I've even had, a prospect I was talking with that they use just simple stack, Snowflake, embedded Tableau, and DBT. And they sell that as a SKU within their online product. And they just serve that up. And you would think like, really? That's enough? And for them, that's enough. They're making money. And it just blows my mind that you don't have to go all the way to this extreme of like intense, like have to start learning React and do all the software engineering thing to actually use data to like sell a compliant product. But I think I'm thinking even back to 2014 version of Sung, where I was using something called audit command language. So think proprietary version of SQL for accountants, and it's as awful as it sounds. And the reason why we had to do that is because it was approved by, the SEC, for Sarbanes-Oxley compliance, because what it does is they were really good about logs where it's like, hey, you did this join. Here are the records dropped as a result of that join. And here's maybe a preview of those records. So it's like, hey, did you drop, certain cash inflows, right? So think signals for, hey, what did you like, make sure debits equal credits, even simple things like that, so that there's like balanced books, right? And so I've even seen from a regulatory perspective, people needing to use something like a DBT with logs to show to like a government board of like, hey, like, here's our logic. Here's how the sausage is made. We're not trying to hide anything from you. So there's that.
Wow, special DSL for accountants. That sounds scary.
Yeah.
And I think in my mind, something else that I'd add on is not just like the quality of the data, but I think when you think about kind of like doing things in a very rigorous, like well-governed way, the very formulaic way that DBT forces you to kind of like create artifacts is also kind of like the proof is not just in the logs and in the putting of like your actual data, but the fact that, like if you're using kind of like a git-based deployment and CI/CD, the fact that you can always like have your entire DBT project version controlled. So then if you are like, you can answer like exactly how calculations were done at any point in time using DBT kind of tools like snapshots. You can also kind of like rewind your data set at any given point in time, actually see what some of those values are. In my mind, it's not just kind of like, the proof is not just in the pudding of like getting your results right in the moment, but being able to like go back later and answer those questions in retrospect of what was done and when and how and why, I think can be like also like super powerful and add a lot of confidence.
Yeah, I think the auditability of anything in the world of data pipelines is probably going to be one of the key themes or challenges for scaling, right? Because the more people contributing, the more complexity and the more business builds the kind of mission critical use cases, the more you kind of have to understand how the code base evolves, the data evolves, and how the code and data are kind of interacting with each other. Any other compliant thoughts?
Yeah,
Okay,
I mean,
so
it was already
sorry.
mentioned, but we basically also leverage snapshots whenever something is going into use cases that are reported externally, be it for like accounting and tax, like legal related things, or in investor stakeholders. And in those cases, you usually use snapshots to being able to like go back in time and see how certain data points ended up in the report that we sent out at some point. And yeah, pretty basic, but like really important tool for us.
That makes a lot of sense. Awesome. We are coming up at our time. So I want to say huge thank you to everyone who came today to attend the meetup. Huge thank you to all the speakers who prepared lightning talks today. I think I personally learned a lot and really amazed by just the thoughtfulness of everyone in terms of developing tools and processes for scaling data and people. Thanks, Sung, for stopping by and sharing your perspective from seeing a lot of success and horror stories as well. And also big thanks to Sarah, my colleague from Datafold, who helped put this event together. Wouldn't happen without you, Sarah. So thank you so much. Before we part, couple of things in terms of events and follow-ups. So this was recorded, so we'll share the recording with everyone who've attended and also who've missed but registered. Next Data Quality Meetup will be focused on the topic of data migrations. So if you are in the midst of migrating from something really scary and slow to something really awesome, that probably will be helpful to you. That's just a topic that's been coming up a lot in the data community recently, and there's a lot to uncover there. Migrations are scary, go over budget, and sometimes not even complete at all. And that's probably going to be sometime in the summer, so stay tuned for the announcements. And in 2 weeks, we will also be running a virtual hands-on lab about using DBT with DataDiff. It's an open source tool that we developed here at Datafold that helps analytics engineers build faster by being fully aware of the impact of their changes. So if some of the topics around auditability and how does the data evolve with the code and compliance are relevant, please stop by. The idea of the virtual hands-on lab is that we will walk everyone through how to set up open source DataDiff with your DBT project. It's 3 easy steps, and hopefully you'll walk away with some superpowers for your analytics engineering workflow. So thanks again, everyone, and happy scaling. Hope that next time we see you all, you'll be all running in the hundreds and thousands of DBT users in your organizations, all compliant and high quality. So thanks again. Have a good rest of your day, and we'll be in touch.
All right. Appreciate
Bye-bye.
you all.
Bye.
Yeah.
Peace.